In this video, we're going to be looking at the properties of polymers. So, what are the properties of polymers? Well, polymers are very poor conductors of heat and they don't conduct electricity either. And they're also chemically unreactive. There's not really many chemical reactions that a polymer will undergo. So, what are the good points and bad points of this unreactivity? Well, the good point is that we can use polymers to make containers to store many different substances, and we can rely on the fact that the container won't react with the substances it's storing. The downside of this unreactivity is that once you come to dispose of a polymer, say for example to a landfill site, it's going to take thousands of years for the polymer to decompose because it's so chemically unreactive. So, how do we affect the properties of polymers? Well, the properties of polymers are affected by two things. Number one is the monomer used to make the polymer. Now remember, the definition of the word monomer is it's the repeating unit of the polymer chain. And also the reaction conditions. So the conditions used in the chemical reaction can also affect the properties. I'm going to talk about reaction conditions first. When you are talking about reaction conditions, you should discuss polythene, okay? Now there's two forms of polythene. There's low density polythene, which is represented by LDPE, and there's also high density polythene, which is represented by HDPE. So if we look at LDPE, and LDPE is the type of polymer used to make carrier bags that you get in supermarkets and stuff like that, okay? If you want to manufacture LDPE, you have to use a very high pressure of 2,000 atmospheres, so that's a pressure 2,000 times greater than the pressure here at sea level, and a temperature of 200 degrees Celsius with just a little bit of oxygen, and that's going to result with polymer chains that look like this, okay? So if you look at these polymer molecules, they've got these side branches coming off them, okay? And because they've got these side branches coming off them, this prevents the individual polymer molecules from getting close together. And because they can't get close together, that results in the low density of the polymer. If we look at high density polythene, okay, the reaction conditions used for this is a much lower temperature of only 50 degrees Celsius and a pressure of only 80 atmospheres. And the reason why the reaction conditions are much lower there is because we use a catalyst for this process. Now this results in the formation of polymer molecules which are straight, no side branches. So because there are no side branches on these polymer molecules can get much closer together, and that results in their high density. So the two types of plastics you really need to know about are thermosoftening and thermosetting. If we're looking at a thermosoftening polymer, that's a polymer that when you heat it, it will soften and melt, and you can reshape it, and you can keep doing that process over and over again. So you can heat it, reshape it, let it cool down, and you can do it over again, and it can always be done. Now the reason why this can be done, if you look at the structure of a thermosoftening polymer, we've got these long polymer chains, and they're sort of arranged in a tangled web. Now these individual polymer molecules are attracted to each other by intermolecular forces. Now intermolecular forces aren't a very strong force, okay? So every time you apply some heat, it's enough to overcome these intermolecular forces, and hence the plastic will melt, okay? And that allows you to manipulate it into whatever shape you want. If we look at a thermosetting polymer, now a thermosetting polymer, that would be the type of polymer you'd use to make an electric kettle. Say for example, when you boil a kettle, it doesn't melt and soften and lose its shape, it retains its shape time and time again. So how does that happen? Well, the first time you heat a thermosetting polymer, it initiates a chemical reaction. And the chemical reaction results in these cross-links being formed between the individual polymer molecules. Now these cross-links are actually covalent bonds. As you know, covalent bonds are strong like all chemical bonds, so you need to put a lot of energy in to overcome them. So that means when you heat a thermosetting polymer, it's not going to melt because there isn't enough energy to break these covalent bonds, hence the polymer retains its shape. Now, an example of thermosetting polymers is if you go to Asda or supermarkets like that and they make you a pizza, they wrap it in a cling film. Now this cling film is a type of thermosetting polymer. In this video clip here, I'm going to show you that what happens, okay? So what's happening here, the lady is wrapping the pizza with a soft, easy manipulated polymer, okay, and she's wrapped it up. Now there's a lot of excess polymer underneath, and she's going to heat it. Now once this is heated for the first time, that's initiating a chemical reaction, okay, and the properties of that polymer is now changing, okay. It's now forming cross-links between the individual polymer molecules, and that's going to give it a much stronger property, okay. And the pizza's the cling film's nearly finished. And hopefully you'll get to see the end of it now when she turns it over. There's me telling her to turn it over. And you can see the polymer here is a much stronger polymer. It's much tougher to break. Okay, so that's an example of thermosetting polymerization in action for you. Okay, so to summarize, the properties of polymers, okay, are determined by the monomer that's used, okay, and also the reaction conditions. And when you're talking about the different reaction conditions, you're going to talk about high density and low density polythene. Okay. We've also talked about thermosoftening polymers. These are polymers where the individual polymer molecules are held together by weak intermolecular forces between the individual molecules. Okay. Where thermosetting polymers, once they've been heated once, they form strong cross-links. And remember, a cross-link is a covalent bond, and that's why they retain their shape when you heat them time and time again. I hope you found this video useful. Thank you.